Okay, what we're going to do today is go over the binomial theorem. I just wanted to first tell you that if you have any questions on 9.4b homework, I put the answers, the solutions, a video of me doing the problems online. You can find that on Blackboard. If you still have questions, then just see me next time you see me, you can ask. All right, 9.5 is the binomial theorem. We're going to use the binomial theorem to calculate binomial coefficients, use Pascal's triangle to calculate binomial coefficients, and use binomial coefficients to write binomial expansions. So what a binomial is when I have the quantity of like x plus y and I raise it to some power. By using the binomial theorem, I'm able to write this expansion quickly without actually having to take x plus y times x plus y times x plus y. The binomial theorem and Pascal's triangle make it so that I don't actually have to FOIL that and then redistribute. I can just recognize a pattern and do it that way. So first, let's talk about binomials. If I have binomials that's raising, to different powers, this is what it looks like when I expand out to the fifth power. I want you to pause the video and see if you can come up with as many patterns as you can see. Okay, some of the things that you should have noticed is that there are one more term than the power. So for example, if I'm raising something to the second power, I have 3 terms. If I'm raising something to the fifth power, I end up having 6 terms. They're symmetrical. In other words, if I look at this x to the third, my x goes 3, 2, and then 1, understood to be 1, and then there's no x at all. At the same time, the y, there's no y, then it's y to the first, y to the second, y to the third. So as the x's are going down, or the first term, your power is going down, your second term, your power is going up. At any given time, when I look at the powers of these, add the terms. So if I look here and I add those powers, 3 plus 2, that's equal to 5, and that's what I'm raising it to. And that'll be true of every single term in that binomial expansion. That's the third one. And then coefficients increase and then decrease. So if you look at my coefficients, it goes 1, 4, 6, 4, 1. They are symmetrical. The 1s are the same, the 4s are the same, and then that 6 is in the middle. When I get to an odd one, I have 1, 5, and then both 10. Actually, that's even the other one's odd, but you know what I'm saying. All right, let's talk about how we do that. First of all, we have what's called the binomial theorem, which is in your book. It's saying that if I expand a binomial, it starts with the x is raised to whatever power that I'm raising it to, and then that power will go down, y will go up, and then this should look familiar to you from last year. That is a combination, which is a statistical thing, and that's how I'm going to find the number that I should put in front. That's how I come up with the 1, the 5, the 10, the 10, the 5, and the 1, is by doing that. Some things that you should know. So let's talk about how we simplify a combination first. So the combination, if I have combination 9, 12, that's going to be understood as 9 factorial over 2 factorial. Then I take 9 minus 2 and I get 7 factorial. The 2 and the 7 should always add up to the top one. Then refreshing our memory of what we did last section, we do 9 times 8 times 7 factorial. This is 7 factorial, 2 times 1. The 7s will simplify, 7 factorials will simplify, the 2 and the 8 will simplify, and I'm left with 36. If I can also write a combination like this where I just use the parentheses, that's still understood to be combination 11. 4, from probability, that's like 11 choose 4, if you want to think of it that way. Again, I do 11 factorial over 4 factorial. 11 minus 4 is 7, so 7 factorial. And I'm left with, and a shortcut that the book shows you is this number here, which is 4, means that I have 4 factors. So I'm going to have 11 times 10 times 9 times 8. And then the bottom, I'm going to have 4 times 3 times 2 times 1. That, because from 7 on, 7 factorial on, will simplify with this 7 factorial. That's why I don't have to write this. So that's another shortcut. So then I do the math and I get an answer, which I'm going to pause. When I do all that math, I get 330. So this one is a combination 8 choose 0, which means I have 0 factors, or I'm going to have 8. So when I start this, I'm going to have 8 factorial over 0 factorial. Remember, 0 factorial is defined as 1 times 8 factorial. So when I simplify that, these will simplify, and I'm just left with 1. So when I go to do the binomial expansion using this, and once the fifth term, what I need to know is that when I do this, the way I think of it is, if I'm raising this to power, the power of the y is always 1 less than the number of term. So when I'm on the fifth term, I know my y is going to be raised to the fourth power. My x is going to be raised to the third power. And how I got that is the 4 plus the 3 have to equal that 7. If I'm in the fifth term, this y is always 1 less because the y starts with 0. So to get to the fifth term, I would only be at 4. When I go to do the coefficient, these two numbers match. So the 4 and this 4 match, and I start with 7. That's the power that I'm raising it to. So off to the side, I'm going to do 7 factorial over 4 factorial, 3 factorial. And again, I'm left with 4 factors, so 7 times 6 times 5 times 4. Actually, I probably should have done it the other way. 4 times 3 times 2 times 1. And then I'm going to simplify this, hopefully. And I'm left with 35. So my coefficient is 35, x to the third, y to the fourth. Again, I didn't have to expand the whole thing. I didn't have to write x plus y 7 times and FOIL it. Oh my gosh, what a nightmare. All I had to do was do the combination to find the coefficient and then my terms. So let's talk about Pascal's triangle. Pascal's triangle is a way of doing the binomial coefficients without doing the combination. So Pascal's triangle, you start with a 1, then 2 other ones, then 1, 2, 1. And how you got that 2 is you add this 1 plus this 1 to give you a 2. To start the next row, I always start with a 1. Then I'm going to add the 1 plus the 2, and I'm going to get 3. I'm going to add the 1 plus the 2 above that and also get a 3. And then I always end with a 1. To get to the next row, again, I start with a 1. Now I'm adding the 1 plus 3, and I'm going to get 4. Add the 3 plus 3 and get 6. Add the 3 plus 1 and get 4. And then end with a 1. Doing the next row, I'm going to start with a 1. Add the 1 plus 4 and get 5. Add the 4 plus 6 and get 10. Which I should have switched colors, I didn't. Add 6 plus 4 and get 10. 4 plus 1 and get 5. And then end with a 1. So now doing the next row, I'm just going to skip all that. Go 1, 6, 15, 20, 15, 6, and 1. And that pattern keeps on continuing. So if I want to expand a binomial, let's say I want to take x plus y to the third, because that's the one we've already talked about, I'm going to go to the row that has the 3 as a second term, because that 3 matches the power that I'm raising it to. Then I'm going to know that my variables, so x will start to the third, then there'll be no y, and then the x will go x squared, y, and again, those exponents have to add up to 1. Then I'm going to have x, y squared, so 3, 2, 1, and then the y is going 0, 1, 2, and then I have to add with y to the third, no x. My coefficients are going to be 1, 3, 3, 1. So 1, 3, 3, 1. So that's how I quickly get the expansion as x to the third plus 3x squared y plus 3xy squared plus y to the third. So on the next slide, I've expanded out Pascal's triangle to the 11th row. Remember, since I start with a row of 1 on top, so this is actually the second row, this is actually the third row. So if I wanted to do the coefficients, use the 10th row of Pascal's triangle, technically I'm starting with 9. It would be raising something to the 9th power when I use the 10th. If I didn't want to actually construct the whole triangle, I could do combinations of each. So I could do a combination 9, choose 0, combination 9, choose 1. And that way I don't have to do the entire triangle. I can just put these into my calculator, or I could figure them out. Shouldn't have said calculator. So this I know is going to be 1, this is going to be 9. But when I do the 9 factorial over 2 factorial, that would be 9 times 8 over 2 times 1. Again, I knew I would only have 2 factors here, and that would be 36. What's interesting, though, is when I look at here, when I do combination 9 choose 7, 9 choose 7, it's going to be the same because, again, order doesn't matter if I take 7 factorial times 2 factorial or 2 factorial times 7 factorial. It's going to be the same. So this is also going to be 36. And so then in order to expand this whole thing, I only have to do 9, 3, 9, 4, 9, 5, because 9, 3, and 9, 6 will be the same, and then 9, 4 and 9, 5 will be the same. Does that make sense? I think it makes sense. So again, I've already done it over here. So I should get 84 and 126. But what you should notice is that it's symmetrical. So I have 10, 10, 45, 45, 120, 120, 210, 210. And then sometimes you have that oddball middle guy. Sometimes they match. So it is symmetrical. The left side looks like the right side. So how do I use this when I go to expand a binomial? So if I have something like this, right, the expansion of x plus 2, this is an easy one. In Algebra 2, we use boxes, and you're more than welcome to use boxes. So let's construct a box. I'm raising this to the 4th power, so I am going to go back to Pascal's triangle, or figure out Pascal's triangle, and I am going to use the 4th row. The way I remember is this matches my power. So I'm raising it to the 4th power, so I want the row that has 4 in it. So why am I going the wrong way? Nobody knows. So I'm going back this way. So I'm going to have 1, 4, and I can't remember 1, 4, 1, 2, 3. Oopsie, made my table wrong. Hold the presses. Let's just start this all over again. So I am going to make my table. I know that I'm going to have 5 terms because I have 1 extra term from the power. I believe it was 5. Well, why did I make that so small? No one knows. Oh, hold on. I'm just going to live with it. You're going to just have to tell me to live with it. So I want 1, 4, 5. Okay, so I'm going to put a 5 here. Those come from my triangle. Then I'm going to think of x. So the first term, which is my first term, I have x to the 4th. Then I have x to the 3rd. Remember, those powers go down. X squared, x, and then finally I'd have x to 0, which would just be 0. Then this last row is going to be for 2. So I'm going to have 2 to the 0. Write myself a note. 2 to the 0, which is 1. 2 to the 1st, which is 2. 2 squared, which is 4. 2 to the 3rd, which is 8. And 2 to the 4th, which is 16. Then to do the expansion, I'm going to multiply my coefficients. So I'm going to have 1 times 1 times 1. And I'm going to end up with x to the 4th. Now I'm going to multiply the 4 times the 1 times the 2. And I'm going to have plus 8, and then it's x to the 3rd. Multiplying here, I'm going to have 5 times 1 times 4, so that'll be 20 x squared. Then 4 times 1 times 8, which is 32x. And then finally 1 times 1 times 16, which is 16. So this is the expansion of this without having to write it all out in FOIL. So let's do some that have, let's do one with the negative. So this one is also raised to the 4th power. So I'm going to basically make the same table that I just made. I'm going to get my top numbers from Pascal's triangle. So 1, 4, 5, 4, and 1. I can squeeze that in there. Then this is y. So y to the 4th, y to the 3rd, y squared, y, and then y to the 0, which would just be 1. Then this one, so this is my y, well, this is my negative 2. So this one is going to be negative 2 to the 0 power, which is just 1. This is negative 2 to the 1st power, which is negative 2. This is negative 2 to the second power, which will be a positive 4. Negative 2 to the third power, which is a negative 8. And then finally, negative 2 to the fourth power, which is a positive 16. When I multiply my coefficients, 1, y to the fourth 1, I'm going to get y to the fourth, multiplying my coefficients here, 4, y to the third, negative 2. It's going to be negative 8, so I'm going to write minus 8. Minus 8y to the third. Now I'm going to have 5 times y squared times 4. Notice it's positive, so I'm going to have plus 20y squared. Don't know why I switched colors. Then I'm going to multiply here, 4y negative 8. So that's going to be negative 32y. And then finally, I'm multiplying the 1 times the 1 times a positive 16. And I will get plus 16. And that's the expansion. I want to do one that's, let's do one like this. Here I have 3 minus x squared to the fifth. So now I'm going to have 6 terms, and I'm using the fifth row of Pascal's triangle. So I can either figure out the fifth row of Pascal's triangle really quickly, or I could go look it up. I'm committed to figuring it out quickly. I don't know why. All right, so when I do this, I'm going to have 1, 5, 10, 10, 5, and 1. Notice that they should match. The 1 and 1, the 5 and 5, the 10 and 10. This row here will be for the 3. This row here will be for a negative x squared. So here I'm going to start with by raising 3 to the first power, 3 to the second power, 3 to the third power. Whoopsie, did that wrong. Oh! So you said, okay, let me try that again. 3 to the fifth power, 3 to the fourth power, 3 to the third power, 3 squared, 3 to the first, and then 3 to the 0. Going the other way, this will be negative x squared to the 0, negative x squared to the first, negative x squared to the second, negative x squared to the third, negative x squared to the fourth, and negative x squared to the fifth. It's easier for me to go this way. This will be 1, 3, 9, 27, 81, 243. Then this will be 1, negative x squared. This will be a positive x to the fourth, negative x to the sixth, positive x to the eighth, negative x to the 10th. Multiplying down, I'm going to have 243 plus 405. Oh, it's actually negative, so let me make that negative. So I'm going to make this a minus sign. Minus 405x squared. Then this will be plus 270x to the fourth minus 90x to the sixth plus 15x to the eighth minus x to the 10th. And that's the expansion. Okay, now I want to show you what's going to happen if you have coefficients for both the x and the y and you have two variables and how that's going to look. So again, I'm raising this to the third power, so I'm going to use Pascal's triangle that has, and if you don't like Pascal's triangle, you can use the combinations. I just think it's quicker to write Pascal's triangle than doing each separate combination. So this is the row that I'm using, so I don't need to go any further. I'm going to make my box. I'm only going to have 4 terms, but I'm going to make my box larger so I can see what I'm doing. So this will be 1, 3, 3, and 1. This row will be for 3x. This row will be for 4y because I'm doing term by term. So when I go to fill in this box, this one will be 3x, and I'm going to raise that to the third power. Then this will be 3x, and I'm going to raise that to the second power. 3x raised to the first power, and then finally 3x raised to the 0 power. Going the opposite direction, remember now my powers are ascending, going up. This will be 4y to the 0, 4y to the first, 4y squared, whoopsie, squared, and then 4y to the third. Now, when I raise these to the power, I'm actually going to raise the x and the 3. So 3 to the third is 27, and then this will be x to the third. This will be 9x squared because you have to do the coefficient as well. This is 3x, and then anything raised to 0 power is always 1. Now, doing the next one, I'm going to do 4y raised to 0 power, which will just be 1. Anything raised to 0 power is always 1. So this will be 4y. Then this will be 16y squared. And then finally, this will be 64y to the third. Now, when I multiply, I have to remember to multiply everything, all the coefficients. So for me, it's easier. Sometimes when I'm doing these and I'm in a hurry and I don't want to mess up, which like now, I tend to write the variables first. So I'm going to do like x to the third. The first term is going to have x to the third. The second term is going to be x squared y. Then it'll be x, y squared, and then finally y to the third. Remember, the x's go 3, 2, 1. The y's go 0, 1, 2, 3. So now I have the x's out of the way, so all I'm really focusing on when I multiply is my coefficients. So I'm doing 1 times 27 times 1, and I get 27. Then it's positive because I didn't have a negative sign, so all of these are going to be positive. So I guess I could put those plus signs in now. Now what I'm going to do is I'm going to multiply 3 times 9 times 4, 12. 108? I hope it's 108. Mental math, 108. Now I'm going to multiply 3 times 16. Oh, don't you wish I had a calculator? So when I multiply the 3 times the 3 times the 16, I get 144. And then finally, I'm going to take the 1 times the 1 times the 64, and I'm going to be left with 64. So there's the expansion without having to do a lot of work. Okay, next one. Sometimes you might just have to find a certain term. So this one's asking me to find the fifth term. So remember, if I'm finding the fifth term, then the second term, this 2b, is raised to the fourth power. This a would be raised to the, well, fourth power as well, because 4 plus 4 have to equal that 8. Now I have a choice. I can go back to Pascal's triangle, and I could, you know, if I have it written out way back here, and I'm raising it to the 8th power, so I could do this, and I could count 1, 2, 3, 4, 5, and I know the answer is 70. But let's say I didn't have Pascal's triangle written there conveniently for me, and I'm going the wrong way again. You guys need to stop me, but you're not here to stop me. So when I could do a combination, since I'm only looking for one term and don't need the entire triangle. Remember, this matches this here, and I start with 8, which is the degree here. So off to the side, I'm going to have 8 factorial over 4 factorial, 4 factorial. So I'm going to have 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1. And I'm going to mentally do that math oh so quickly. Maybe, and I get 70, which is what I was expecting. So that's 70a to the fourth times 2 to the fourth, 2, 4, 8, 16, 16b to the fourth, which you should write it like that. So now I'm going to take 70 times 16, and when I do that, I get 1,120 a to the fourth, b to the fourth, and that is my fifth term. Find the coefficient of the term that has, this time they're not telling me what term I'm on. They're telling me that they want the term that has a to the fourth, b to the seventh. So when I do that, I know that I took this negative 3b. This negative 3b was raised to the 7th power. This 2a was raised to the 4th power. And now I need to find my coefficient that goes in front. Again, my degree, what I'm raising it to is the 11th power. This matches this, so I'm going to do combination 11, choose 7. So off to the side, I'm going to do 11 times 10, whoopsie, times 9 times 8 over 4 4 times 3 times 2 times 1. Again, I'm using that 4 and 4, which I should really be using 7 and 7, but you know, it's the same thing. And then here I'm going to do 8, 3, 30, 330. So this coefficient is 3. Oh, oopsie. I hate it when that happens. Let's see if we can do that. This coefficient is 330. The 2 to the 4, 2, 4, 8, 16, 16a, and then negative 3 to the 7th. Whoa. 7 times 1, 2, 3, 4, 5, 6. 2,187b to the 7th, and then I'm going to multiply all those together. And when I do that, I get 1154730 a to the 4th, b to the 7th, and I forgot to put 4 there. Okay, I hope this helps, and here is your homework, and good luck.